My name is Kevin Libby. Good to virtually see some of you on camera here, and we'll jump into this. So we're going to touch on OpenBAS. This is our open source breach and attack simulation platform that we can take some of that threat data and finished threat intelligence and push it in from our direction. And then as we go through, and we'll touch on some of these elements as we go through the just walking around the platform and testing out a real life simulated, I'll say, attack scenario. And we're going to use Typhoon as the backdrop towards this. So let me just pivot over to a different screen now. So before we push this in to OpenBAS, our open source breach and attack simulation platform, I just wanted to give a little backdrop on, I'm sure most of the folks in the room are very aware of the threats out there, the general threat landscape, and the different typhoons, Typhoon specifically for today. But I won't put you to sleep too much. I know you just ate a lot of food, but we'll just go over this. So Typhoon, for those that need to be aware, is a Chinese-sponsored threat group. They've been active since around mid-2021. And we have some information in here within our platform to help us build out an effective simulated attack scenario around this threat group. So we know things around Typhoon that they've been primarily targeting critical infrastructure sectors in the United States. They know that including manufacturing, utilities, transportation, etc. We have an idea of the group's primary objectives. We have some tactics and techniques, so capabilities associated with Typhoon. So we know that Typhoon likes to live off the land a little bit there. We also know that there is typically some kind of involvement around exploitation around network appliances. So they like to exploit vulnerabilities around networking devices, vendors such as Fortinet, Netgear, Citrix, Cisco, etc. There's also use of compromised devices for command and control exfiltration. Let me back that up. Typhoon tends to route its C2 traffic through compromised home office routers and other network appliances. So they create effectively multi-hop proxies that I can't talk today, obfuscate their operations. Yeah, I guess my coffee level is quite low. Anyway, so we have an idea of the adversary's capabilities, intent, some of their victimology around that. We also, from different sources, have a wealth of information to go reading through this. So as we get our arms around Typhoon and want to put out a more relevant and real world attack scenario, step one is really getting what we're showing here, that high level idea or that high level insight around the threat group, including any indicators of compromise, etc. Once we have all this, we can then build out let me just push that over. We can then build out a good attack pattern. So I'm going to let my platform generate this for me. In OpenBAS, our open source breach and attack simulation platform, obviously, you can build this out from scratch and heavily modify it so it meets your environmental needs and your overarching risk a little bit better. And of course, I don't have every single TTP covered, or I should say every single attack technique covered, but that's what we get for demo environments. So I have an intrusion set for Typhoon built out. These are all the different payloads that I would like to run as part of my simulated attack to my endpoints. And I'll just make sure that I update this with my endpoints here. Cancel. There we go. So I'll take all these different injects that are going to go down to my endpoints, and we can quickly modify some of that. And my mouse is giving me some issues today, so I'll skip that part. So we know that, again, back to the tactics and techniques that are associated with Typhoon, we know that we want to run specific payloads to mimic those tactics and techniques. So let me just jump into OpenBAS really quick and give a high level of the platform. So I've already mentioned multiple times, it's our open source platform that really allows organizations to better create attack simulations. But really what it does, it also helps cybersecurity teams set up the continuous monitoring of their security posture. So we pull all this in, and I've already created an attack scenario now that mimics Volt Typhoon. So we can kick this off, and it's going to take a little while because I'm just hitting some Windows endpoints in my lab environment. Once I kick that off, this attack scenario is supposed to really go through this logical flow and run this end-to-end simulation of Volt Typhoon's attack tactics. Now, we could also launch, while this is running, we can talk around a few other things. We can also launch specific atomic testings. So maybe we had a payload that we were from Volt Typhoon that we were more specifically interested in. We could just pick that up and shoot that out the gate to a target. We can also leverage the human element. We're not going to do that for today's purposes, but with a lot of the tactics and techniques that these threat groups leverage, the human element, the phishing, the spear phishing, that having that built into some of these simulated attacks can be incredibly important. So, but again, for today, we'll just ignore that one. And how we do this, again, while this simulated attack is running in the background, just for your aware, our asset group, this is small for demonstration purposes, but we have a few different Windows endpoints that we're running this particular simulated attack against today. Now, it could be others. We could build that out, of course. And how we do that is at those particular payloads, we have different agents running. We're using OpenBAS agent today. That's our agent that comes with our open source platform. But obviously, if any of the folks in the crowd decide to try this out sometime, it's free to use. There are other built-in integrations that we support too. For example, Tanium and CrowdStrike and Caldera. So let's go back to this attack scenario now and see where we are. So it's still ongoing, and it does take a little while to run through all of this. So again, just to go through the different injects that we're running right now, we're hitting external remote services, we're activating a guest account, and so forth. Again, this is all to mimic Volt Typhoon. I have a question, actually. Are we in a position where we are able to take questions from the audience while this is running? Because it does take quite a while.
Yes, if you can hear us, the mics are on.
Yes, sir, I can.
So let me ask, are there any questions? Patrick?
I have a comment. So just so you folks know, I had intended to be running this on this OpenBAS and the simulation.
Pointing at his Raspberry Pis.
Yeah, I'm pointing at my Raspberry Pis. And the three on the left were going to be the targets that he's running against. Okay, so was not able to get the ARM64 images built to actually run this, but the point is that OpenCPI, OpenBAS, MISP, and all that are running on this, and the intent for the demo here was those three Raspberry Pis on the left were going to be my targets to run this simulation against. Thank you.
Any other questions while we're...
What version of Docker are you running on this?
Did you hear that?
The question is, what version of Docker?
Yes.
Sir, I am unaware that I have a team that built this environment up for me, but I can definitely go field that question and find out for you.
I appreciate it. Thank you.
I will be a subject matter expert on that in a couple of weeks. You know, I'm serious.
So this is Duncan with a question for you. So the machines that you're doing the attack, you use the word attack simulation. The machines that you are attacking, are they simulated or are you actually attacking them?
It's a simulated attack. So these payloads get pushed down to the endpoint, and the endpoint facilitates that simulation, if you will. So it's not meant to, the endpoints push it out to that local machine to instigate that, and then it does what it does. It just simulates that attack. But
simulates it in the sense of the Windows machine actually gets the, say, malware installed on it?
Well, a simulated piece of malware. We're not actually pushing the real.
You only
malware.
talk to your agent, so to speak, and pretend you're doing it, or do you actually do it?
We can make, for example, we can make modifications against registry. We can try to enable a guest account, that type of activity, but we definitely do not want to be pushing real life malware down to the endpoint, if that makes sense, if I'm answering that correctly.
Well, I just want to understand what you're doing. So if I were to set one of these up, to copy Patrick's, make another hut of Patrick's of my own, and to do it, I would want to do this against my honeypot machines, not against my live machines, correct?
Or a sandbox.
Or a sandbox, or I wouldn't want to do this against my live network, or would I?
You could. Again, that's going to be payload dependent. That's a good question. So we have around 1,600 different payloads that we pull in from Caldera. Some of these we've also developed ourselves, and we have customers that build their own. The majority of the payloads are all very benign. Because obviously these are supposed to be simulated attacks. Now, the difference between benign and not necessarily benign is really the intent of the user behind the scenes. So it's similar to many tool sets out there that have good intent for validation of security controls, including pen testing and other offensive engagements. Some of those can be misused.
Would you recommend running this prior to a job going into production? In other words, as part of the pre-production testing and acceptance?
Absolutely. Now, this is not meant to replace any type of web app scanning or OWASP vulnerability checking, or I should say just general vulnerability pen testing or anything like that. Vulnerability checking. We're not saying, hey, you haven't patched something. This is simply looking for tactics and techniques associated with threat groups or that simulated attack that you built out.
You're targeting a specific family of vulnerabilities?
No, but if there's a vulnerability that takes advantage of a loose control, a loose security control, that's what we're looking for. We're not trying to replace the Tenables or the Rapid7s or all the vulnerability management and monitoring solutions out there. That's not what we're doing. We're trying to validate security controls in an environment.
Are you working with Secure by Design based on that? The Secure by Design says turn on all the controls, let the customer out. Are you doing that?
That's up to the target. That's not up to the machine. This is the attacker, not the. They're simulating the attacker, not the.
It's trying everything.
No, that's not what this is. This is running explicit exploits against us.
This is pretending to be the Chinese attacking.
Yes, there we go. Thank you.
Hey, Kevin, could I ask just a clarifying question? But you support the full functionality of Caldera, for example?
Yes, we do, sir.
So whatever I can do with Caldera, I can use with this, correct?
You can use the Caldera payloads within OpenBAS, and you can also leverage the Caldera endpoint. If there is additional features or functionality on the Caldera side that we have not yet built into our platform, then there's going to be a little gap there. Our platform this is our open source breach and attack simulation platform that's been out. We just released this late last year. So we do have a long way to go to cover some of those gaps, but we want to socialize this around all of our peers, the industry. We want to encourage people to help us get our arms around some of these security control gaps.
I think we have any more questions in the room, but so I'll ask another one. So from the alphabet soup that we went through earlier, which, if any, do you have anything to do with? So do you take sticks as input or do you have sticks as output? Do you have OpenC2? Do you have IOB? Do you have TAC? Do any of those make any sense in your context, or are they sort of all orthogonal?
Good question, sir. And yeah, I'll be more than happy to answer that. So OpenCTI, our threat intel platform that I initially took all the tactics and techniques out of to build out that attack scenario, our entire underlying data model is STIX 2.1. And from that, That's where we understand the relationships between all the different objects and actually can build out this good intrusion set so we can have a more real world and near real time attack scenario built out, because all of this can be automated to be ran, daily, weekly, whatever that needs to be for that particular environment that needs to be tested. So it is all sticks under the hood.
So it sticks on the input side. What about your answers? Now if you say, hey, yeah, this attack worked, does that produce a sticks object?
Not yet. Not yet, to the best of my knowledge. Again, we still have quite a bit of ground to cover for everything from remediation guidance out the gate, and also some of the outputs that would be fed back into the original OpenCTI. It will be sticks when it's completely done, but we're still building some of this out.
Good answer. And by the way, you can always add on your answer, and it's open source, so you can help with it if you want.
Well, absolutely, sir.
Let me help Kevin here if I can, as an OpenCTI fanboy. They also have connectors for CrowdStrike. There's connectors for processing text files for CSV structured
That's
data.
all proprietary stuff. I just care about standard. So back to you, Kevin. Has it finished?
No, it has not. It's going to take quite a while, it looks like.
Is it going to take longer than your time period? You still have 15 minutes, but I'm just checking.
Yes, it will.
So let me Raspberry Pi cluster for you.
let me just fast forward a little bit. So when it's all done, the idea is, of those different payloads that reflected the tactics and techniques of Volt Typhoon, the idea is that when that is run, you'll have an understanding, were any of those payloads prevented? If so, what controls prevented them? Were they detected? If so, what controls detected them? And if not, where was that gap? And then where we're going, of course, I'm talking a little bit futures now, where we're going with that is, once that gap is determined, here is some remediation guidance on how to close that gap. Again, we're not completely there yet, but it is open source and it's free for all. And I will copy and paste the links to the software, to the documentation, and to a large amount of YouTube videos for here right now for the audience. And hopefully you can consume some of that, of course, when time permits.
So Kevin, the picture we're seeing now with prevention, detection, and human response, I'm assuming the green is where the thing defended successfully and the red is where the attacker won, or is it the other way around?
The green is where it was detected successfully and the red was not detected. That evaded it.
So the Chinese worked pretty well on your examples here, I'm saying. Nothing, very little got prevented. A fair amount got detected, but a third got through, and your human response was pretty horrible. Is that what I'm reading?
Well, yes, yes and no. So you're interpreting the visual correctly. However, this is a cumulative visual of all the different scenarios that we've been running in this particular demonstration environment. Not necessarily specific to Volt Typhoon that I'm still
Obviously,
running.
because it hasn't finished yet. Good point.
Yeah, correct. When this is finished, you'll be able to see, it'll come, it says no data to display right now, but when it's finished, it'll be prevention, detection, and of course, human response. So it'll be more granular. And then of course, you can drill into it a little bit more. There's nothing coming back yet from any of the MITRE attack results. So again, you'll have little cool prevention, detection, and human response color coding.
You had a bunch of other data up there. Do you have a previous run you could show us?
Not for Volt Typhoon.
We're seeing the very first attack line.
Yes. Well, I did run this the other day just to make sure it was working correctly. But I did not save that one. But we do have some other attacks that, I mean, these are just one-off primary atomic testing that people have ran, and that was not me. So I don't know. I mean, there's a lot of tests ongoing right now. It looks like we have quite a few people using this. Like this one, this is someone just ran some atomic testing around DLL side loading. So this is not associated with Volt Typhoon, so I don't want to dive too much into that. But let me copy and paste those links, and I encourage everyone to jump in there. And of course, Dan Wilkinson, who's also on this meeting along with myself, are here representing Filigran, and we would be more than happy to field any questions down the road through email, or we can spin up a meeting and we can certainly guide you towards using our open source software, should you wish to jump off of that. And yes, any feedback and input, and if you want to be involved in our open source community, please do so. Everyone's more than welcome. And thank you for allowing us the opportunity to stand in front of you today virtually and just plant some seeds.
Thanks. Do you want us to wait the remaining, do you think it will finish in the next 10 minutes, or should we? Well, first let's ask, are there any other questions or any other?
That is hit or miss.
Yeah, we got another question in the room.
Okay.
Why is it taking so long to run? And is there anything you're doing to improve the performance of it? Because if it's gonna take this long to run, I don't know how many companies are gonna start using it.
Well, remember the real Volt Typhoon, they do over days and weeks, so you could argue it's still running pretty fast, but.
But you're gonna be checking this every day. It could
So,
take, you know, because you don't know when that's coming in, so you have to constantly monitor it. Is there a way of running a streamlined test?
You can run it on your own gear, and then it's up to
Yeah,
you.
it's like.
yes. So it's a good question, and it's certainly valid. For today's purposes, we are using just simply a lab and demo environment that gets used quite frequently by myself and my team, and it's overutilized. I'll say that. In a real world environment, it would be especially the lab environment that are containing the virtual Windows machines would be more robust, certainly. So yes, we can add a little more horsepower to this and speed things up. But the platform itself is not the hindrance in this case. The hindrance is really those endpoints pushing out those payloads. And we also have a built-in delay in between each payload as part of that attack scenario. It's 2-minute gap between each one. Now we can reduce some of that, but remember, we're trying to evade the technical controls. So if we just spit everything out in 30 seconds, it's obviously going to trigger some controls easier than others. We definitely don't want to cause some kind of denial of service situation or trigger any easy low-hanging brute force attack type flags.
Anybody on the web has any questions, please put them in the chat.
Hey, Kevin, I'm gonna try to help you out here again. So, you ran this demonstration for us, and we had it was less than an hour-long session, if I remember correctly.
Correct.
We ran through the simulation.
Yeah, but I don't know if you just noticed there were 12 other people running.
That's what I'm trying to get to. Is I think you ran it on your own environment the first time, it wasn't loaded, right? What I'm
Correct.
trying to say is we went through this whole thing. There's a video link in the chat for Cask and everything. So we ran this and did it successfully with Q&A under an hour.
I picked it at a less busy time. There was another question from the back.
Is there a way to specify this for different infrastructure like water versus electricity? Or if you're just looking at infrastructure as a like total and penetration testing that?
Did you hear the question, Kevin?
I heard the first part, differentiating between different infrastructures.
Yeah, so can you specify it? So if you're looking at water safety, if you're looking at, let's say, electricity, is there a way to specify it for that? Or is it just infrastructure in like totality and you're just penetration testing whether or not you can get into that environment?
So the test was put together by the intrusion set that was wrapped up around that threat group. Now, modifications could be made to the intrusion set that planted the seed for the entire attack scenario. That could be one way to do it. Another way to do it would be to go into that attack scenario and modify either the different payloads being sent out that reflect those initial tactics and techniques. You could go through and modify some of that again, every single payload has quite a bit of granularity around it. I apologize, I stopped sharing. Let me just jump back in and I can kind of explain a little bit. Each one of these injects, you can go in and get a little bit more granular on what you might want to do for that payload. Everything from injecting specific documents to manipulating around some of the extension IDs and the rest of it. And every payload is going to be very different. That there are different ways.
Not sharing yet, just
Oh.
if you think you are.
Thank you. There we go. I think that. Okay. User error today. So yes, you can go in and modify either the initial intrusion set to better reflect what you want ultimately your target to be, but that's also takes away from some of the more real world parts of that intrusion set. I think the real answer would be response to your specific question, and I apologize I didn't catch your name, would be to go through and start to manipulate some of the payloads and the assets, the targets of what you're going to be testing in the first place. Again, for the purposes of my testing today, I'm just hitting a few Windows endpoints, but they don't have to be Windows endpoints. They could be other things that reflect or more accurately reflect that particular target infrastructure.
Yeah, so you can put use Salt Typhoon or Flax Typhoon as opposed to Full Typhoon, and use routers instead of window. I mean, you can tailor it to be what you want it to be.
Correct.
Thank you, Kevin.
All right, so with that, we're gonna steal a couple minutes away from you, Kevin, so that we can let the next talk go. But at the end of the next talk, if you would keep your simulation running, we'll give you those couple minutes back at the end of the next talk, and hopefully you can then show us the results. Hopefully by half an hour from now, it'll be done.
Well, fantastic. Thank you.
I'm gonna turn it over to In the Room to Charlie, who's gonna look at basically the same data, but from a slightly different perspective.
So, hi again. I promise this is gonna be a little bit less scary than my pre-lunch talk. And probably a little bit more boring. But my name's Charlie Frick. I'm a staff member over at Johns Hopkins Applied Physics Lab up in Laurel, Maryland. We're a university-affiliated research center that's been around for about the last 80 years, doing various types of studies and support across mostly public sector, a lot of DoD work, and getting the screen where I can see. A lot of work for the DoD, the IC, CISA, and different parts of critical infrastructure. And folks have mentioned some of our previous work here today already. We did a lot of work in the area of security automation, starting about roughly 10 years ago, under a task called Integrated Adaptive Cyber Defense. And I promise there's a reason for my rambling. In that work, we really looked at the idea of starting off what's now called security orchestration, or SOAR, because the speed and scale of the cyber attack is greater than what we're currently able to respond to. And we need a way to really react at machine speed. And we just say that sounds nice. It's more than just us reacting by ourselves. What we're seeing with campaigns like Volt Typhoon is we are targeting community, we're targeting sectors, and we have to be able to respond as a sector. And due to that, rapid sharing of threat intelligence to enable automation is key. We've seen this many times over. And if you ever want a longer talk on that, I have plenty of other use cases and pilots we can get into. But as we started looking at that, that got us into this idea of needing what we're calling indicators of behavior. And roughly, these are machine shareable objects that represent the effect of an adversary's intent. So if you don't take anything else from this talk, before we get into looking at my graphs and talking about analytics and threat emulation, and right now, often we are searching for how the adversary did what they did. We need to search, in my opinion, for what they are doing instead of exactly how they're doing it. Because we are making very detailed, very precise analytics that take too long to create, take too long to import, and aren't reusable. And we have to redo it every time they make a slightest change in their procedures. So I'll get into what I actually mean with all this. And this goes back, I'd be remiss if I didn't acknowledge, I have a very large team, can't name them all, but one person in particular, Ms. Kimberly Watson, who's over at the multi-state ISAC nowadays. She and I were doing a lot of ideas on this concept going much further back in 2021. But in 2021, APL and CISA, our main sponsor. I also wish to acknowledge the Cyber Threat Information Sharing Team at CISA and the capacity building. They've been sponsoring us for years, and they are one of the key champions for this research. We saw a need to partner with the OTA on this Indicators of Behavior project. I'm going to go over the concept and talk to you about our reference implementations that we have put out there, and we're going to do a little bit of deep dive of what we use IOBs for, with the Volt Typhoon case as our main example. That said, the other thing I want you to take away is if you're interested in any of this stuff, we have worked so hard to make almost every artifact that we do publicly releasable, publicly available. It's mostly distributed through GitHub, but that website, opencybersecurityalliance.org/IOB, that will bring you to a high-level YouTube video to go over the concepts I'm talking about today, and have you links to download and pull just about all the tools and capabilities that I'm going to talk about. So getting back to the concept. We're looking a lot right now, sometimes in my opinion, at the wrong places. Threat reports are doing a great job of giving us the chain of attack patterns. But by its very nature, we like to tell ourselves that MITRE ATT&CK is a framework for TTPs. That is a lie. MITRE ATT&CK, you can read the matrices, it's for tactics and techniques. Any intersection on there are dozens of procedures. And this sounds a bit in the weeds, but that really impacts what you can go detect when you want to find things. And I am grateful for MITRE ATT&CK. It's giving us a common taxonomy. It's giving us the right advice, pointing us in the right directions. But a lot of our operators still need to be able to interpret a lot of nuance to know exactly what to look for and what to do about it when they have to take action. We want machines to be able to do this. Anybody that's worked in any type of automation knows first and foremost, computers are stupid. They're fast. They're not smart. LLMs, your ChatGPT, is not smart. It is using very complex mathematics, looking at the pattern of human language over the entirety of the internet to guess what the end of a sentence is. In the words of George Carlin, cleaned up for today's talk, take your average idiot on the street, half the world is dumber than that guy. ChatGPT is going to go after the most common answer to any question. Sometimes that's right. Sometimes it's wrong. Mathematically, it can't know that it's wrong. It knows that it's supposed to give you an answer. So we need to think about, how are we going to train these? What data are we going to give this automation? And so that got us thinking about detection analytics. As I said, there are phenomenal detection engineers in this audience, out on the Zoom, all over the planet, and they're making really good detection analytics that are meant to look for a specific thing and have a very low false positive. Because anybody in here doing EDRs knows the horrific nightmare that a 1% false positive rate causes at scale. Anybody that's not, go look it up. Because we like to think, researchers, pointy-head people like myself are like, oh, it's just wrong 1% of the time. 1% of the time is going to be $20,000 cost to a small, medium business every single day. That can't be tolerated. So we make detection analytics that are very specific, but we're always having to chase after that. That got us thinking, how do we do this a little bit differently? Instead of trying to find the exact string, mutexes, extract these very finite things from registry entries, what if we look more at what's the bad guy trying to do? And what are the rough symptoms that we can observe from infected networks and infected computers? And that creates, things like these little blue behaviors here. A machine gets an email that had a slightly higher risk score than normal on your security plans. A machine's running PowerShell for the first time. A machine has a registry modification. Machine starts accessing new network shares. Every single one of those blue boxes is a god-awful, terrible analytic for any SOC operator to be responding off of. They're going to have millions of false positives. So we wanted to change how we look at this. I want to share analytics for stuff like that, not for a person, but for a machine. But they're useless by themselves. I need to show a way to correlate them. I'm not as interested in whether this alert fires or what value is in this alert. I'm interested in, across 4 alerts, what values are equal between the alerts. Is the machine that got a slightly riskier email running PowerShell launched from an attachment that was in the email? I can see the process execution with things like Sysmon on Microsoft. Did Outlook spawn Office, and that Office process spawn PowerShell to spawn commands? That chain is in there. There's not one search that does that because you're not looking for one log, you're looking for 4. And you want to see what's common between them. That's what your really good threat hunters and SOC analysts are doing. That's what Kestrel is written to help codify that. We want to see how we can package this up and send it to communities, ideally, so that MSSPs and vendors will be able to process an open format into their platforms, because I can't control what an entire community buys. I never will. So we need a way for that community to share that type of data and how to correlate it. And deep down, this is because we have to have something more proactive than indicators of compromise. Those of us that have been working in automation, I think we're really getting to the limit of how far we can push automated response to indicators of compromise. Because unfortunately, when you want to enrich indicators to find out what you should block, and that's good, solid practice. And I wish to God that the bad guys were stupid. But it turns out the APTs can look up virus total as well. And because they're not idiots, when their command and control IP is publicly broadcast as a command and control IP, they change it because changing an IP takes a millisecond. And it doesn't cost them very much. Same with their domain names. And anybody, a lot of programmers here, it ain't that hard to pad an executable to have a different file hash every single time I distribute it. Now that said, we have to check for indicators of compromise, because if your company gets hacked and your boss finds out that somebody had the file hash that you let through that didn't check because somebody reused it once, well, that's a bad day, and it's a bad day for your company. But we need more. And if we can find a way to look for these trends, not being as specific, but really seeing a correlated set of symptoms, think of it kind of like triage in medicine. That's going to help us a lot. So to do that, we need to take advantage of some open standards. For us, most of IOB are extensions to something called STIX, Structured Threat Information Exchange. So you've heard STIX mentioned a lot. What I'll say here again is it's a standardized JSON format for conveying threat information as a knowledge graph. You're going to see me draw a couple funny looking pictures with lots of colored balls and data in a second. But knowledge graphs are objects of data that have relationships. STIX 2.1 has a very well-defined spec, as our good friends at TypeDB have been learning. And a nice element of STIX is you can define extensions. And Oasis manages STIX, and also the Open Cyber Alliance manages a repository of STIX extensions. All of our indicator behavior extensions are available freely there, along with documentation. And this allows us to codify what we want to convey. And most of my research here, I'm not claiming to be a great detection engineer. I'm not claiming to be a great threat emulation guy. I'm not even claiming to be a good threat analyst. I am a nerd. I am a mathematician with a theater degree that took a lot of weird turns in life. And I am interested in trying to define the structure to enable this capability to share this type of data. Also, you'll often hear STIX in coordination with TAXI. TAXI is a very also interesting open protocol standard for exchanging information like STIX. And part of the demo I'll do in a few minutes will take advantage of some great work that the folks here at Paraton have done with a TAXI platform known as IMX. which I think is indicator message exchange. I'm looking over and I see some head nods. I got the name right. Okay. But when I talk about knowledge graph, before we dive into all the different toys and fun stuff, essentially, you want to think about a combination of information you want to convey to your community. And so the lighter blue boxes, that's me saying, here's an example of receiving a fish, computer downloaded a macro-enabled file, computer exhibiting strange DNS traffic. There can be legitimate reasons for all of those. Though, as a very biased human being, if you do have a computer resolve a DNS address 10,000 times in one day, you're hacked, okay? That's not how DNS works. But we can use space sticks to have our observables, our supporting information, and our attack patterns, so we have that common language to talk amongst ourselves with. But we can share these behaviors, but the behaviors by themselves aren't so helpful. You know, one behavior, I can say right now, password cracking. Bad guys use password crackers to crack hashes they stole. Nobody in this room will ever be using something in their sock to detect somebody doing offline password cracking. Because they're not gonna, the bad guy doesn't let you install your Splunk agent on his password cracker. But for the behaviors we share, we want to share detection analytics. And those can be encoded in, with this standard that we promote, you can encode your analytic in any format you want. A lot of our examples will use something called Sigma. I'll show an example of that a little bit later of why we use that one. But you can use sticks patterning, you can use the stick shifter structure that is also an OCA project. But along with the detections, what I've been trying to say is we have to share how to correlate this. This is going to be an automated playbook. The examples I'll show today are going to use Cacao. We've also used business process modeling notation in the past, because we've been looking at some of this kind of prior to Cacao, as Cacao was getting stood up. But we're going to show you why we like using an open format like Cacao, because how it will enable some of our other tools. And then as you detect something, then you can also, if you wish, start sharing your courses of action to take action on it and response playbooks as well, and package all of that up and send that out via taxi or other methods if you wish to your community. But rather than just talk about it, we wanted to make examples to share with the community. So one of the main things we do on this project over here at APL is we maintain a few different reference implementations. Our main one is currently about 3,500 lines of JSON. I won't read them all to you in this talk, but we built a representative sample on an APT case known as APT 37 or Reaper. North Korean spearphishing campaign to escalate privileges, move around the network, and exfiltrate data. And I'm not trying to make the Reaper bundle for you to test against the insert funny name in front of an animal campaign tomorrow morning or the next one. I'm looking to give you a spearphishing, escalating privileges, laterally movement, and stealing data sample so that you can reuse this. Just like when I show you Volt Typhoon, I'm not trying to give you a Volt Typhoon to give you the Salt Typhoon, to give you the Petunia Typhoon, or whatever else Typhoon is going to come next. I want to start sharing I don't know how they got in. I'm not going to track down all these CVE 0 days or potentially stolen creds, but I want to find endpoint accounts being manipulated to steal credentials in order to conduct reconnaissance, steal larger sets of credentials, and maintain rogue access chain of events. And the example I'm going to go through in a few moments. But to help explain all this, we build a representative sample of an IOB bundle based on Reaper. And again, not claiming to be great at threat emulation. The good folks at Filigran are looking at some very different applications to test your controls. For my team, we were trying to test the effect on the victim machine. So we just kind of took advantage of some of our more offensively focused staff and read through the threat narratives, and we recreate them in our own environment. And so we use the same tools that a lot of the adversaries use. And then we also conduct user emulation, where we put little agents on the enterprise networks to do things like visit the internet, write emails to each other, access file shares and make Word documents or Office documents, just so that we can have background noise in the logs. Because another big cardinal crime of researchers like myself is we attack networks that have no benign activity, and we develop analytics with a signal to noise ratio of 1, and then send it out and say, why are you guys so dumb? It's so easy. And yeah, it is easy when you have nothing else to look at but a threat, but that's not real. So we want something a little closer to reality. And we built our own orchestrated, security orchestrated workflows to correlate and respond, and then encode those in Cacao, package all of this up, and share that and make that available through our website. Said all that so that I could explain the demo that I'm going to do. But I want to tell you a little bit about the tools that we also offer. Not a big commercial, this is all open source. I am selling you nothing. Everything is free. Feel free to use it. More importantly, feel free to look at what I make, say that it's not as good as it could be, and go make something better off of it. No pride of ownership. It's all free. It's all under, I believe, an Apache 2 license for the OCA. Take my stuff and make something cool with it. But there's a lot of great threat intel platforms out there, and I have great respect for all the tip vendors we got. I wanted stuff because I'm broke, I'm poor, and I have to be able to, do stuff, rapidly. I wanted a very simple, very, very simple way to just visualize and analyze the knowledge graph that I'm trying to build with these IRB models. For that, there's lots of good platforms. I'm personally, with my team, using Neo4j. That's an open source graph database. There are lots of good graphs out there. I'm not trying to make one over the other. But since we were doing that, we wrote some code and some Python scripts that we made available that will take any STIX 2.1 bundle and translate that into a Neo4j database. Because the STIX standard, while it conveys things like objects and relationships, there's a lot of nuance because it's a fairly complex standard meant to hold a very wide array of information. So we maintained that script for folks, but the other thing we saw the need for is a lot of us that like to work in data and work in data standards, we have another personality flaw, I know I have it, and that is either ourselves or our teams are all computer programmers. And we think, oh, we made a Python library, we've saved the world. And the shocking thing that a lot of my team always struggles with is understanding that most stock analysts that I work with can't write Python. They cannot write bash scripts. They are not computer programmers, they are analysts. And that not all analysts write code. And if you say, well, they should, smack yourself across the head, because I come from the arrogant place in Laurel known as APL, and that's not okay. You have to think about where your community is at and reach out to them. So for that, and again, I promise, I go through a lot of twists and turns, but it's for a good reason. We were looking at some open source tools for creating STIX models through a graphical user interface, something an analyst might want to build. And I don't know, anybody here raise your hands familiar with a group called the Cyber Threat Alliance? A couple folks. So CTA is a really fascinating nonprofit. I'd say a very large portion of your security vendors, the large ones, participate with CTA. They're a knowledge sharing organization. What happens is to be a member in good standing for the Cyber Threat Alliance, you have to provide a quota of unique indicators of compromise per day, and it's in the thousands. Every member has to provide a unique set daily. CTA's got capabilities and platforms that are evaluating those submissions to make sure you stay in good standing. A member in good standing gets access to the whole ocean of everybody's submissions. So this is a way that they can guarantee everybody that receives from the pool is putting in their fair share. They understood very well that a lot of the threat analysts in these companies needed a better way to understand how to package the information that you'd want to encapsulate in STIX. So their CTO, the late Jason Minnick, he worked really hard to make a GUI for STIX, for building STIX, and he open sourced that. Unfortunately, I said he's no longer with us, and as we were looking at it, we wanted to be able to have some new features. Like specifically, a way to add custom objects, define sticks extensions, feed them into this tool, and let people have new elements for their modeling. So we made a fork and updated it and got that distributed out on GitHub. I'm saying all this to also share kind of the happy ending to the story. Is one of the things that we're really happy to share at this event, and we've mentioned in a couple of our project meetings, is as we've been doing this, the Cyber Threat Alliance has reached back to us. And we are beginning some more formal collaborations to see about taking this tool and letting them begin to take ownership of it again through their public open source release to take these new features while crediting the OCA for our contributions. And more importantly, they are reaching out to the IOB project for formal collaboration to modify the back end of their data sharing platform to support the indicator of behavior standards. And that provides a common interface for most major security products on planet Earth. And if we want vendors to be able to take these tools, this is a very good incentive for a place for them to connect and receive IOBs. And we will be also working on expanding the things that get offered to help organizations build and distribute. So that was my big news announcement. Taken a while for us to get to that point. And with that, I think it's a good time to get into the so what. What does all this really mean? So let's start with the very exciting element of a Unix command prompt. So I mentioned real quick that sticks, and don't worry, the screen is going to look mostly black. It's okay. I promise it's not going to be here for long. We're taking advantage of a common standard for sticks that also can take advantage of standards like taxi. By having a well-defined public standard, vendors can take advantage and make lobbied offerings. The good folks here at Paraton have built a really cool taxi server called IMX that distributes not just bundles of sticks objects, but they can really process that knowledge graph, and they can read in new extensions and modify their data model. Anybody that has worked in a commercial threat intel feed understands that being able to dynamically change the structure of the object shared is a much harder problem than it sounds like. Normally we keep it static and we truncate out everything we don't understand. This platform is able to ingest new extensions and rapidly add to the type of data you can put in your feed, which is really good because threat intel is rapidly changing. On top of that, it can do some neat things like walk that knowledge graph. And so I'm using curl. They have lots of good clients. I'm just being a little bit, old school here for a second, but I can just live hit that server and that return. Here is an indicator of behavior bundle, all the elements and everything that the graph is connected to. And on the back end, it can walk that down and send that data down to me. Similarly, and we'll talk a lot more in a second, the type of data that's in all that JSON logs. One example coming right here. Let's see if I can make that a little bit easier. And I have a typo in there, but that's okay. This is an analytic that I share normally. This is from our Volt Typhoon bundle. So if you remember me talking earlier, I said one of the things that Volt Typhoon does is they steal copies of something called the ntds.dit database. I'm really hoping that's the one I put up here. Yes, it is. Good. Now, I can look for a file hash of the malware that executes that process. I can look for a registry edit. I can look for all sorts of things in a very complex analytic. If I stop for a second and say, okay, they're making a copy of the database. Well, Windows Event Code 325 creates a record every time an Active Directory server writes a copy of the ntds.dit database and logs that. Now, are there false positives there? Yes. Maybe someone's making a backup. Maybe there's another tool that needs to make copies of that database. But this is the type of analytic that's not going to change unless we change the standard log for when that database gets copied. This is an analytic a machine can look at all day long and then see if there's other analytics to correlate against to say whether this was done for a good or bad reason. These are the type of searches that we're going to share in our indicator of behavior bundles. Now, let's have a little bit of fun with graphs. So I mentioned we have a Python script. I'm going to run it right now. And we'll call this demo. And I'm running something locally. Let's see how badly I fat finger everything. And here is our living off the land bundle for today. All right. And now I'm going to go into my graph. Now, we're going to try and make this a little bit bigger. Now, looking at the whole graph by itself, you're going to see a really ugly blob of different stuff. And each of these colored balls is a different type of data object within sticks. And this has got a little web of connections. And we're not going to talk about all of this today, because really, I want to get back to that kind of core that I was talking about. So if you want to look at this next search I have up there, really, what I wanted to talk to you guys about is the main things I want to share. I might need other objects to get into a lot more nuance. I have a lot of documentation on GitHub where you can read about all the other edge cases. But really, I've got attack patterns from a certain campaign that happened that have some relationship to behaviors. Those behaviors have a detection analytic that can detect them. I'm going to want to group those detections and feed those into a correlating course of action that has a playbook telling me exactly what automation to run to correlate and find this threat. When you think about it as that type of connected graph, you can really narrow the search pretty quickly into something a little bit more manageable. And so let me subject you to this real quick. And we'll make this a lot prettier. So this is the painfully boring part. But I'm going to have a chain of behaviors, and we're going to take a look at what these mean in just a second.
Charlie, you don't have a Gen AI thing to do that for you?
You know, you caught me on the one. There are a couple tools that will automatically align these by a lot of different mathematical algorithms. And I am having my team work on one that just saves a bunch of XY coordinates that I can dump to the side so I can repeat this, which is what a lot of people end up cheating in graph analytics. And anybody who's doing the graphs knows exactly the very painful reality that I'm dealing with at this moment. Okay. So down here in the light blue, I can click an item, and this is all the data that was in that JSON object. This is from MITRE's attack sticks repository they maintain on GitHub. But these are my attack patterns. Now here, as I was saying, I'm not sharing anything about the initial access. We could have another talk on like zero-day exploits and some behaviors you observe on networking equipment, but I wanted to kind of look at a different part of this kill chain that's more repeatable across the Volt Typhoon families. So very common observation is on the initial victim, there's a lot of credential hash extraction from LSAS. That's a application that's built into Windows. We're also looking at loading of PowerShell scripts to enumerate networks. From there, use of those credentials to log into an Active Directory and a copy of the NTDS file. Then some network-based things for looking for Windows remote commands being executed, looking for new RDP sessions that haven't occurred before, and a lot of that's looking at how you copy things from, say, the user account from one alert if it shows up in another, and then a couple of little weird things. And maybe the last step here of deleting logs might be the trigger to look across other alerts. Each one of these is going to be tied to an analytic. Our analytics are encoded in here, but now keep an eye on the time. Don't worry, Duncan. But these are, well, and now I got to move that little zoom window. Okay. These decode pretty rapidly.
Oh, a lot of time.
I know. Oh, don't worry, I need it. They'll decode it into these things that I'm calling sigma rules. And so you saw one earlier when I showed that example pulling from the taxi server. Now that was dynamically pulling it down. After I have this and ingest it somewhere, I can have these rules in Sigma format. And I talked about, and I'm going to give a quick note on Sigma. Well, if I can. So, like again, there are multiple ways it's going to happen. And Sigma is one approach we like, that it's not a scene by itself, but it is a standardized representation of the type of search that you might run through a scene. Now, there is a lot of debate on how much scenes are used. You can have your analytic in other ways if you want to think more in a more EDR, XDR format as well. But right now, I want to share exactly what to look for in the logs. And Sigma has a lot of free tools to translate across different offerings, open source, proprietary. Folks can write their own connectors. But this is a format where I can share a rule and automatically translate it across the different vendor stacks in my community. This is one example, just how our reference implementation is doing it. But OCA has a project called Stick Shifter that's going across the same idea, but looking heavily at sticks patterns and sticks observables to translate across different, search formats. Kestrel is a hunt language that can store a sequence of those. But we want a way that we can share this type of data, because while I can run my own code manually to change these. The idea is we're looking at automated pipelines that we can ingest this data, rapidly transform, test, and insert into our members' infrastructures. Or if you're a vendor, rapidly translate and insert into your tool's decision logic. And about to have more fun with drafts. Additionally, I'm going to show you guys this whole idea about playbooks. We're going to hit one I believe button, but as I said, I share with you how to correlate and score behaviors. Okay? And well, that's the BPM one. I share in multiple forms. There's BPMN, which is a XML-based standard for showing a process, and then we also have Cacao. Now, if you're willing to just hit the I believe button, rather than watch me extract this with JQ and test the formatting and save it to a file, it's a plug fest, and I wanted to show the value of having an open standard that, for me to understand what to do with that playbook, I can parse it, I can make a reader, or I can take advantage of the fact that using an open standard like Cacao instantly gave me a format for Cacao Roaster, where not only can I visually inspect this and understand the process, sometimes a playbook is going to be taken by hand and a team is going to manually do the correlation. And that stinks, it's not fast enough, but they don't have any other capability. We're looking to change that. And I don't want to steal any thunder from Cacao Roaster demos later, but they've been working hard to integrate with open platforms to execute these playbooks. And when I say execute, Mateus talked about this in his lightning talk, but 5 minutes is a short amount of time to cover a lot of detail. These playbooks, you can see, I've got lots of variables. These are going to be created as I run the various decision logic and run through this playbook. And fingers crossed, this will expand out. All right, every one of these steps. Now here, in this example for the Plugfest today, I didn't have time to integrate in a orchestrator and a scene and my whole environment over in our village. That's exactly why Patrick's building what he's building, so that over the course of the year, we can do that. And I'm excited about that. So right now, these are manual steps in here, but for each of these blue boxes is checking the different alert fields. And when one starts the workflow, there's a step to go correlate and check. I'll go back to the simple view, hopefully. And basically, my automation is going to run in the background, trigger whenever one of these detections fire, I can turn them into something like a SIEM alert or an EDR notification, or maybe a network appliance alert. I can use those as triggering mechanisms to check the other analytics. And when I see enough correlations, now I'm doing a very simple example here, but saying, hey, if just one fires, there's 1 point firing. That's not enough for anybody to have anything bothered to do. Could be a false positive, it's not worrying. But maybe if I have 3 or more of these things that look like they're linked together, and each comparison is going to have a different time window for what's relevant. Like when I want to think about a spearfish process launching something malicious, that's going to happen in milliseconds. When they double click the attachment, it's going to execute, that's going to execute another process, going to execute another. That's going to be a very short time. Now, if I want to look for that machine starting to enumerate a network, that could be within a couple of days. It might phone home, and if they have pretty good tradecraft, they're going to have some delayed ops to stand there, gain a better foothold where they're at, and then slowly enumerate the network. You're going to have different time windows you correlate again. And so this has to be running because it's not going to be just one. It's going to have to run constantly in the background. Let's say once I got more than a point, maybe I have 2 of them. Okay, well, do I have more than 3? So if I have between 1 and 3, maybe that's a low priority that goes into a digest. We've done that a lot within the case of compromise before and said like, hey, here's some data that we're not certain this is super bad, but we want you to be aware of what's happening by the automation. You can check this digest at the end of shift. But maybe if I see a lot more of them, I'm like, hey, I really think you have something bad here. Let's automate an integration with your ticketing system, your event management, case management, whatever you want to call it, and let's get a human involved at this point. This is the type of data that we want to share. And there's a little bit more I wanted to take advantage of, and I've got the time to do it, so I am. At its core, what I just explained to you guys is I'm trying to build a standard to represent more repeatable analytics and ways to correlate them. That sounds very repetitive. It's just a lifetime of also doing a lot of teaching for high school kids, and so I'm used to having to say every message 7 times. Anyways, there's another reason why we're so interested in this, because one of the first complaints I get is, well, this is just a never-ending cycle. You're going to be building behaviors to the end of days. You're going to need AI to make all this. I do need AI to make all of this, and I need help to develop those capabilities. But like, you're just recreating MITRE ATT&CK only 100 times larger. I disagree. And show you the nugget of trying to help explain that out. I want to load up an additional indicator behavior bundle to show the beginning of a certain trend of why we want folks like the CTA and our vendor communities to start populating a larger ocean of this data, of what I think is the beginning of what we can do with this type of capability. So I've loaded the whole Typhoon case. And I'm going to not talk and type at the same time. And I'm going to load our old Reaper Lite demo, our reference implementation. Oh, come on. Okay. Now, let's go back to that graph for a second. And I'll show everything for a minute. And it's really ugly. Now, one of the things is my point to give away the ending early. There are going to be things shared between these bundles over time, and that's going to let us queue up other ideas. Now, anybody that's a data engineer knows that one of the first things I screwed up here is I haven't deduped or cleaned up any of my data. Let's do that real quick. This is quick and dirty. So these are just some saved queries I've had before for cleaning stuff up. I'm not claiming to be a production engineer, so I am certain many of you have a far better way to do this than I am doing. Oh, come on. Hold on. Okay, let's try this again. Oh, it's over there. There it is. It's the little Zoom plugin hits you at the worst time. So I got rid of I got rid of just 10 nodes, but 155 relationships. And spoiler, that's the big problem with data duplication when you start thinking about knowledge graphs, is you get repeat relationships and that clogs everything up. And if I'm really talking like adding 1 million of these things a day, that becomes trillions really quickly. So you have to clean this stuff up as you load it into the platforms. And there are some other alternative data models that we're very interested in exploring, because I'm hoping that some of what I'm saying has got the type DB guy interested. And it does, he's smiling. All right. So now, and you get to everybody suffer with Charlie's bad use of a mouse. I'm going to bring up that core idea again. And we're going to try really quick. I'm going to cheat for a minute. Just bear with me. I promise there's a reason for everything I'm doing. Even though this part does stink to have to watch me do. But you're going to get the abridged version. I won't let my OCD take full control. I don't have time. And you absolutely should not have the patience. So over here on the right-hand side, this longer one is our main reference implementation based on Reaper Lite. Or sorry, we call Reaper Lite, it's based on the Reaper campaign. I promise there's a reason for why I'm dragging all these little balls around. And let's all be friends and just say, you know, I'll talk. I just really want to talk to this picture and then take some questions. But what I want you to notice is this left-hand side, I have my behaviors in the dark blue. I got the detection analytics. They'll go to a correlation. For my other campaign, got my behaviors, detections, correlations, and this one had some response playbooks as well. And we have the start of seeing a common connection. Both these campaigns are using PowerShell. Now, that's not the strongest link between these two campaigns. Lots of people use PowerShell. But why we're starting to look to share this is as we build more and more examples, the dark blue, the behaviors themselves will start to get repeated in the data shared. So that when we see one family, we now have an easy to walk graph to quickly learn what other analytics we should be looking at, and also queue up, maybe to AI, maybe just to a really exhausted SOC team, we can start queuing up additional playbooks for courses of action to take if we see enough common between multiple data as we build out this ocean. And that's kind of the overall intent and goal that we've been trying to get to by having this common standard to inspire lots of people to start sharing this level of analytic, this level of behavior between platforms. A lot of vendors are thinking of these ideas inside proprietary boundaries. And as much as any company wants, no one company is going to get to own all of planet Earth. We're going to need a way to build something much more complex than any one of us can. And I think, you know, we've been very grateful for all the support from OCA and all of our members to help us move along that path. There's more to do. There always is more. And we're very grateful that we have this collaboration with CTA. CISA is also supporting us as we begin doing operational pilots of putting IOBs into production. So we also are working with the Hudson Alpha Institute for Biotechnology down in Alabama, Huntsville, Alabama. where we are taking some sample IOB bundles and translating that into their security ops to analyze for threats on their networks. And we are doing more research in building upon the automation, because one of the things that we have to do is let automation begin looking for emergent patterns in endpoint and network activity. To begin that's a pretty simple machine learning concept. Start classifying new emergent patterns that we're seeing in the data, but then there's still a little bit of ways to go on how we map that to attack patterns and begin extracting what are the nuggets of new behaviors that are identified. Because I've shown you a case where we're sharing data across community. But if you really want to think about this, as we start thinking more and more automation, these same concepts eventually could be used for things like internal communications of analytic alerts within an automated process. And that's kind of the power of the standard, is that you can begin to morph it and shape it to share that intelligence. Originally we wanted a way to have common threat intelligence shared across our communities and our analysts. That's going to morph into how we share it across computers and how automation and non-human entities are processing this data. And I think it's very important that as a community, we get together and help control what features, what capabilities are packaged into that. Which is why I'm going to end by asking for your help. This project, we want to help influence adoption, but we also want to help influence the state of automated security and also influence the state of information sharing. We're sharing these concepts out to help people. Again, opencybersecurityalliance.org/IOB will get you everywhere you want to go. If you go to github.com, opencybersecurityalliance/OCA-IOB, you can get our documentation, you get our use cases, you'll get our scripts, you'll get sample JSONs, you'll get very boring technical reports that I spent many months writing, and you'll also get things like our Python script, and most importantly, you'll have all the absolute free, there is no financial cost information to join our group. We meet every 3 months. It's a Zoom. Link to join the listserv is on that GitHub. A link to join the Slack is on that GitHub. And you'll have a Zoom invite sent to you via Slack or emailed to you. You're welcome to attend. You're welcome to comment and add to or tell us things we've done wrong. And we listen and we try to respond. A lot of the revisions we put out have been due to our community feedback. And we want you as part of that community. So thank you again for your time. I got about 3 or 5 minutes before we want to check in with our good friends OpenBAS. So with that, I will take any questions.
Thank you very much. I'll start with the first question.
Sure.
So you mentioned the sort of tie-in to your biological work, which
Yeah.
I thought was interesting because I think of that as very orthogonal. Are you doing anything with either, I'm going to say their name wrong because I don't remember the acronym, but I'm going to call it the Space CTI group, the part that's used
Yes,
in space.
Space ISAC. There are discussions going on with that.
Because that's another one where the behaviors are probably very different.
Exactly.
Class of
And
behaviors.
because then you're going to talk about, how you capture behaviors inside something like a satellite.
Right.
And there are some talks there, and I'm sounding cagey because I don't remember which NDA I was on for which task. So that I just can say, yes, we are talking with them and talking with folks from the Space ISAC.
Right, and how about, I don't think there's an equivalent to the space like
Yeah.
that, but how about the IoT world? Because again, that's another area where the behavior is going to be different.
Yes, and so with IoT, there's a lot of stuff that we're looking there. With IoT and with ICS in different routes. IoT is a big reason why we want to look for the dynamic identification of emergent behavior, because there's so much heavy, crazy customization going on that we feel we're really going to need some automated things to identify the patterns, because each device has got some crazy homegrown thing on the back end. And then in ICS,
Industrial control systems for those. who don't
industrial
know.
control system, there's a lot of correlated analytics, particularly in certain communication communities, that we really want to get better ways to codify and the behaviors.
Other questions in the room? Patrick?
So those of us that have engaged with what you got up there in the ILB, and we got the one demo
Yep.
bundle, is there any other resources where we can find more bundles?
So we're putting more in there now. So in the reference implementation, there's an example section where not just the APL reference implementations, we have a couple. This whole Typhoon demo that I just did will be up there.
Okay.
We were looking at, trying to get a couple more network-based detections in there before we posted it, but we might get this in as Rev 0. There's also some dynamic network observation bundles in there right now. And then we also have a couple from the previous CASP events that we've got up in there.
Quick follow-up.
Yeah.
Is there any place for the tooling to generate our own bundles at this point?
Yes, that is available. There's a link in this presentation to get towards some of that.
We're gonna have a question here, but just a quickie, what about Salt Typhoon and Flax Typhoon and any other typhoons?
So we've been trying hard to pick a lot of the behaviors that are common across those campaigns. And we're doing some, as time permits, we're doing some more research into the different typhoons to see if there might be one or two artifacts that we add to our revision in 1 or 2 of this typhoon bundle.
Okay, back there?
Okay, first, thanks a lot, Charlie, for the presentation.
Thank you.
I have 2 questions. For the first one, when you build up like this model, initially, like a training the model, you third party the data or you use, just
Sorry, you're asking how I train?
yeah.
So right now, the examples we made here were not generated from AI.
Oh, okay.
So these were generated through reviewing the threat reports, recreating the activity, and kind of going at it like a SOC analyst, but then trying to think, how do I change what I search for to be kind of follow the overall theme and design.
Okay.
And what we're going to
So
take is,
HI instead of
Yeah.
AI, human eye.
and our whole goal is to look at how we train them, and what we're trying to go to next is how to train agentic AI to follow that process.
Yeah, because I saw you have a lot of simulation. You can use simulation, get new data, you can fit back.
Exactly.
Okay. The second question is, if you use Python,
Yeah.
and use the open source model, development. Then they use another today like cybersecurity stuff.
Mhm.
Do we need it's like the library can change like model or something?
So there is a very robust Sticks Python library, and we are actually too early to announce, but we have been working to get some additions to that to help better accommodate the IOB extensions and looking for partners that are interested in working on that with us.
Thank you.
One more question from John, and then we'll switch back to Kevin. So
So at the graph level.
Yeah.
You're gonna have n number of sticks bundles over time. So there's 2 methods, right? There's a breadth first search or breadth deep search. Kind of scrape across every indication. But then you can do centrality like you're talking about. So you see now a pattern where multiple attackers can be in the same environment doing different things.
Yes. Exactly. And you and I are going to talk, because I think you know exactly where I'm going at. But there's a lot, as this graph gets more complex, there's going to be a lot of nuance and overlap.
You need the inferencing capabilities that a model like Spatial Type DB
Exactly.
likes to do that.
All right, let's give Charlie another big round of applause. We could switch back to Kevin and switch back to the previous OpenBAS, and let's see how our simulation did.
We last left our hero, he was.
I should pull a casserole out of the oven.
Kevin, are you there? You are.
I am, sir. So I found a bug in my lab and I had to restart the attack scenario. However, which is still ongoing, but yeah, we do have some process injects and a timeline now that was supposed to be there the first time around. It was not populating. So it's going to be a little while still. So here's my proposal. Would it be acceptable for me to send in a video of a time-lapsed attack? Because it's this is one of those days where I am at the mercy of my lab and demo gods.
That would be great. That would be especially appropriate. In fact, anybody else who's doing demos, if they could do similar, because we like to, at the end of these events, put the things in the results section you've looked at any of our previous villages, we have basically a results page where we put all the presentations, put the videos, and put whatever we have. And yes, we're not very good at doing it. So it'd be good, the more, again, sort of to all the speakers, to all the people giving demos, anything you can provide afterwards to put in the results. But in this case, yeah, if you could just send us the link, and, maybe show it during one of the breaks and stuff like that tomorrow, that would be wonderful.
Thank you, sir.